Question 6. The equation of the curve C is given by y equals x on 3 into x squared minus 4. Find A, dy dx at the point negative 1, 1. B, the equation of the tangents to C at the point P negative 1, 1. C, the coordinate of the point Q where the tangent T meets C again. All of these 7 points. Sub 2. Given that f of x equals to 3x, or that on x minus 1 into x plus 2, where x an element of the set of real numbers excluding negative 2 and 1. D, express f of x into partial fractions. And E, find the integral of f of x dx. You can find this question paper on the link below this video. Welcome back once more to our channel, and if you are joining for the first time, please make sure that you hit the subscribe button and the notifications bell so that whenever we upload a new video, you'll be notified. We have over 400 and something videos already online, which can help you to prepare effectively for your exams. Please go through those videos and the past questions you have already answered, as well as make sure that you can contact us to join for paid classes online or follow us live on YouTube on Saturdays and Sundays. Please watch this part to the end, and don't forget, hold on, to share this video in at least 10 of the WhatsApp groups in which you find yourself. This is going to motivate us to create more content. The more subscribers we have, the more watch hours we see, the more content we create. The less we have, the less we create. Thank you so much, because we know you're going to do it. Ciao. First part of the question. Find dy dx at the point P negative 1, 1. So the curve is given as y is equal to x on 3 into x squared minus 4. So we can rewrite it as y is equal to 1 over 3 into x cubed minus 4x. Okay, we have just multiplied everything by x inside. From here, dy dx will be equal to, we keep this constant outside, the derivative of x cubed is 3x squared minus the square root of the derivative of 4x is 4. So the derivative of this is going to give us 1 over 3 into 3x squared minus 4. At the point negative 1, 1, dy dx will be equal to 1 over 3 into 3 times x squared. Now what is x squared? The x value is negative 1. When we square it, we are going to have plus 1 times 3, and that's 3 minus 4. So at the point negative 1, 1, the derivative is negative 1 on 3. Now the B part of the equation says we should find the equation of the tangent T to C at the point 1, 1. So the equation of the tangent is given by y is equal to m into x minus x0 plus y 0. In our case here, they have given us the point x0, y0, which is negative 1, 1. At that point, x is negative 1, y is 1. Now we already have the gradient from the A part, because we dy dx was negative 1 on 3. Now dy dx at the given point is equal to the gradient of the tangent at that point. So the gradient of the tangent to the curve at this point is negative 1 on 3, which is our m here. Therefore, our y will be equal to negative 1 on 3, the gradient, into x minus x0. So x minus, our x0 is negative 1, so x minus minus 1 plus y0, which is 1. So when we simplify this, we'll have y is equal to negative 1 on 3x plus 2 on 3. So this gives us the tangent to the curve at the point negative 1, 1. Now for the C part, to find the coordinates of the point Q, where the tangent T meet to the curve C again. What does this tell us? It means they have already met before, because we have the tangent here. So they want us to find the other points where they meet again. Now, at this point where they first of all meet, what is the value of x? What's the root? Or what's the value of x at this point where they met before? Because we know that they met at the point negative 1, 1, right? It therefore means that x equals negative 1 is one of the roots of the solution we are looking for. We are now going to look for another point where they meet again. So at the point where the curve and the tangent intersect, the x value there is one of the roots of the equation. So for us to find the other points where the curve and the tangent will meet again, we have to equate the tangent to the curve. Therefore, in C, we have curve equals tangent. So this will give us 1/3 into x cubed minus 4x should be equal to 1/3 x plus 2 on 3. When we simplify this, we will end up with x cubed minus 3x minus 2 equals 0. But we already know that one of the roots of this equation is x equals -1, because this is where the curve and the tangent met before, or they have already met here. So if one of the roots is equal to, if one of the roots values of x equals -1, it therefore means x equals +1 is a factor. And you can use this idea and long division to find the other what? The other root. Because the first one met at the point x equals 1. Therefore means that x equals -1, which therefore means that x plus 1 equals 0 is one of the factors. So let's divide. So we divide this curve by x plus 1, and we will have x cubed divided by x. What's that going to give us? That's going to give us x squared. Okay? Now x squared times x is equal to x cubed, and x squared times 1 is plus x squared. Now we subtract. X cubed minus x cubed is 0, and nothing minus x squared is -x squared. Now, -x squared divided by x is -x. Okay? For these values, you have not used them, you can just bring them down like this. Now, -x squared divided by x is -x. And from here, -x times x, -x squared, -x times +1, -x. We subtract again. -x squared minus -x squared is 0. -3x minus x, -2x. And -2 minus nothing, -2. We divide again. -2x divided by x is -2. So this -2 now times x is -2x, and -2 times +1 is -2. So at this point now, when we subtract, the remainder is 0. Of course, we were sure that the remainder will be 0 because we knew that x plus 1 was a factor. Now, how do we find the other value of x where the curve intersects with the tangent? We just need to equate this quotient to 0 and solve for x. So the other points can be obtained from, you have x squared minus x minus 2 equals 0. We can factorize this quadratic. That is x minus 2 into x plus 1 equals 0. And from here, x will be 2, or x equals -1. Aha! One of the values x equals -1, which now confirms or affirms or reaffirms what was given the equation before that, or what we used equally, that x equals -1 was one of the roots. Equally that x equals -1 is one of the roots, right? So the other root now is x equals 2, but it's not n here because they want us to find the point. So take this value of x equals 2 and substitute either in the tangent or the curve to find the other value of y. Okay, so at the point x equals 2, y will be equal to 0. If I'm using the curve, y will be equal to 0. Okay, if I use the tangent, it will be equal to 0. I have -2 on 3 plus 2 on 3, which is 0. So the other point is the point 2, 0. Please make sure you subscribe. Do not leave this video without subscribing to this channel. It will be a mathematical taboo. It will be very bad. And if you are subscribed and not click on the notifications, it means you are not serious, because when you upload a new video, you will never know whether you have uploaded or not. So when you subscribe, click on the notifications bell. There's something like a bell beside, click there so that you are notified. Once you upload a video, as you are uploading almost every week, you get a video. Please do that. And one last little favor, if you have not shared this video to about 10 WhatsApp groups in which you are, it means you don't like the work you are doing, you don't like the channel, you hate us. Please do this and encourage us to create more content for you. Thank you, because we know we are doing it now as you are watching. Now the B part of the question says, or the sub 2, that we have the curve y is equal to, we have the function y equals 3x over x minus 1 into x plus 2, and now we should express it in partial fractions. So we can start this denominator has linear factors. So you can just write it as a over the first factor plus b over the second factor. Okay. We now multiply all through by this LCM. That's x minus 1 into x plus 2. And we have 3x is identical to a into x plus 2 plus b into x minus 1. Now at the point where x is equal to 1, we substitute in this equation. we will have this B term term with B will be eliminated. We will have 1 plus 2, 3 times A, 3A will be equal to 3. And from here, A is equal to 1. Now, when x is equal to negative 2, we will have 3 times negative 2, which is negative 6. This term will be eliminated. And we have B into negative 2 minus 1, negative 3 times B, negative 3B. So from here, B is equal to 2. Okay? We can now conveniently write this as being equal to 1 over x minus 1 plus 2 over x plus 2. Now find the integral of f of x dx. This now will be very simple because we have already expressed in partial fractions. So from here, if you look at the denominator of this first part, you differentiate it, you have 1, which is the numerator. So the integral of this first part will just be the ln of the absolute value of the denominator. For the second part, you can bring out the 2 because it's constant. We bring out the 2, we have 2 into 1 over x plus 2. When you differentiate the denominator, we equally have the numerator, which will be 1. So this is going to give us plus 2 ln absolute value of x plus 2 plus a constant of integration. Thank you so much for watching, and this is not the end. The next question is question 7. There are some of our questions online that if you have not subscribed, you cannot watch. If you need the PDF version of these papers from 2011 or 2015 to date, 2023, to prepare for 2024, please use the link below this video or leave your comments and we will get to you and we send you the material, okay, at a little or no token. So contact us for this, and there is more information on those links below. You can follow many other videos from those links and playlists, okay? Thank you so much for being there, and God bless you as you prepare for your exams. If you have chemistry paper 3s, please, students are contacting us that they are in need of them. They have difficulties with their revision. Please help. We know you are doing arts, but you have friends who can help with chemistry paper 3 in PDF form. You can just send to us on WhatsApp. Thank you so much, and bye-bye.